Okay, I want you to close your eyes for a second. Picture a factory, but erase that old image of an assembly line. Even erase the modern one with a few people in hard hats looking at a screen.
Hmm.
I want you to picture a factory of the future. It's pitch black inside, it's quiet, and it's strangely independent.
Independent is exactly the right word. You have to imagine a machine in the corner of that dark room.
Yeah,
And it isn't just, welding a car door.
right.
It's logging into a network. It's bidding on the electricity it needs for the next hour. It's paying for a software patch it knows it's missing. It might even be hiring another AI to optimize its own code.
And the kicker here, the part that really scrambles the brain, is that it's doing all of this without a human manager anywhere in sight.
No purchase order.
No corporate credit card, no procurement department, just the machine, its wallet, and the network.
Exactly. We aren't just talking about the automation of labor anymore. I mean,
Yeah.
that's old news. We are talking about the automation of economics itself.
Which is why we're here. Welcome to the deep dive. Today, we are unpacking a shift that sounds like something out of science fiction machines buying things, but is actually a massive infrastructure project happening right now.
It really is.
We're looking at the transition from machines as just tools we use to machines as, well, as independent economic agents. We are asking the big question, what is the money of machines?
It's a huge topic. And I think, usually when people hear digital money, their eyes kind of glaze over.
Oh, yeah, they tune out.
They assume we're going to talk about Bitcoin's price swinging all over the place or, some crypto bro trying to sell them a JPEG of a monkey.
Which, just to be crystal clear, is not what we are doing today. We aren't looking at speculation, we're looking at plumbing.
We are looking at the financial nervous system being built for a hyper-connected world. And we have a stack of fascinating research here, from a sociological analysis in the journal Capital and Class, all the way to reports from Visa, Andreessen Horowitz, and the Bank for International Settlements.
Let's start with the philosophy of this, because I think it helps ground the technology. You shared this piece by Frank Angster, and I'll be honest, it was a bit dense, but the core idea is brilliant. He calls money a social machine.
It is a dense paper, but the central metaphor is perfect. Angster compares money to a steam engine. Think about what a steam engine actually does. It takes heat and pressure, these chaotic forces of nature, and it quantifies them.
It turns them into measurable, consistent motion.
Precisely. And Angster's argument is that money does the exact same thing for social relations. It takes your effort, or a product, or a service, and it quantifies it. It turns it into a number that can be exchanged.
So money isn't just a coin, it's a technology, a tool for measuring and moving value.
Exactly. But here's the friction point, and this is crucial for understanding that robot in the dark factory. Classical money cash, checks, even your credit card, is a slow machine. It relies on biological validation.
Biological validation, you mean?
I mean us, humans. Old money needs a human hand to pass over the cash. It needs a human brain to authorize a wire transfer or tap the terminal. There's almost always a human in the loop, or at least a system designed around human timescales. And that creates a bottleneck.
Right. I can't pay you any faster than I can physically tap my phone.
Exactly. So what we're seeing now is the removal of that biological bottleneck. We're moving toward money that is fully automated. It doesn't just quantify value, it routes it, programs it, and executes it based on code, not a handshake. It's treating money like a packet of data on the internet.
Which is a wild concept. You don't have a human postman carrying every single email to its destination. The network just handles it. So we're basically doing that for cash. But this is where I get stuck. If we're giving machines wallets, what are they spending? I can't imagine an autonomous truck trying to pay a toll with Bitcoin.
Why not?
Well, the volatility. I mean, if the truck drives up to the toll booth and the price of Bitcoin suddenly crashes 10%, it can't afford to pass. Or maybe it overpays by a huge amount. Machines run on logic, and logic requires predictability. You can't code a budget if your money's value changes every second.
You've hit on the fundamental problem. An AI managing a fleet of vans has a budget for charging, for parking, for tolls. If it holds that budget in a standard cryptocurrency, one bad market day could wipe out its entire operating capital. You can't build a business on that kind of chaos.
So if crypto is out because it's too volatile, and traditional banking is out because it's too slow and manual, what's the alternative?
The data points very clearly to stablecoins. You can think of them as the Esperanto for machines, a universal language that bridges that gap.
Okay, for anyone listening who might just see the headlines and think crypto, let's define that really clearly. How is a stablecoin different from, say, Bitcoin?
So a stablecoin is a digital currency, but it's pegged to a stable asset, usually the US dollar. One token is designed to always equal $1. So you get the technological benefits of crypto, the speed, the programmability, the 24/7 global access, but without the wild roller coaster ride of value.
So it's boring money, but it's fast.
Boring is good for business, and the numbers on this are, 'kay, they're wild. I was looking at the projections in the source material. The market could hit, what, $2 trillion by 2028?
2 trillion. That is not a niche product anymore.
Not at all. And what's more interesting than the size is the use. A few years ago, stablecoins were mostly used as, like, poker chips. You'd park your money while waiting to buy more Bitcoin. But the Visa data shows that business-to-business transactions using stablecoins are already over $36 billion a year.
So that's not speculation. That's real utility. Actual companies paying actual bills.
It is. An executive from Visa called it a technology of pure utility. If you're a global corporation or a machine, you want a currency you can send from New York to Singapore at 3 in the morning on a Sunday for a fraction of a cent.
And have it settle instantly.
Instantly.
Yeah, because the internet doesn't sleep. It's just absurd that our current money, clocks out at 5 p.m. on Friday.
It is absurd. And for an AI agent, it's completely unacceptable. A machine does not understand banking hours.
Let's pivot to those agents then. We've established the what stablecoins. Now let's talk about the who. And we're not just talking about factory robots welding doors. We're talking about software.
Correct. We're seeing the rise of what are called AI agents. Unlike a chatbot, where you type and it replies, an agent can actually take action. It has a goal. And, well, to achieve goals in our society, you usually have to buy things.
Key Sheffield from Visa talks about this in the context of coordination costs. That sounds a bit like economist speak. Can we break that down?
Sure. Coordination cost is basically the friction of getting things done. It's the headache factor.
Yeah.
So let's say you're a researcher. You need to write a deep dive on some complex medical topic. You need to access 20 specific papers from 20 different journals.
Oh, I know this pain. I go to 20 websites, create 20 accounts, I have to verify my email 20 times, I pull out my credit card, type in the numbers, and then my card probably gets frozen for fraud because I made too many small transactions.
That is high coordination cost. It's hours of wasted time. Now imagine you have an AI research agent. You give it the topic, the agent identifies the papers, it negotiates with the journal's APIs, and it executes micropayments, maybe 50 cents a paper, instantly from its own wallet. It downloads them, summarizes them, and hands them to you.
And I do nothing. The agent handles all of that economic negotiation.
And the friction just drops to almost zero. But there's an even bigger implication here, something the venture firm Andreessen Horowitz calls the invisible tax.
This is the part about content creators, isn't it?
Yes. Right now, AI models train themselves by scraping the web. They read news sites, blogs, Reddit threads, everything for free. And this is a huge controversy. Creators are saying, hey, you're using my work to build your brain, you should pay me.
It's a parasitic relationship at the moment. The AI gets smarter, the website just gets a bigger server bill.
It is. But machine money lets us flip that script. Imagine a future where, as an AI agent crawls a website to learn, it pays the creator in real time. A tiny micropayment for every article it reads or every image it analyzes.
That solves the whole fair use legal nightmare. You create a direct economic link between the robot reading the site and the human who wrote it. You turn the AI from a parasite into a customer.
Exactly. It creates a sustainable ecosystem.
Huh?
And there's always a but.
I was going to say, this sounds a little too easy. If I'm a website owner, or a bank for that matter, how do I know this agent is actually going to pay me? How do I know it's not some botnet trying to crash my site?
That is the security hurdle. In traditional banking, we have KYC, know your customer. You show your ID, proof of address.
Right. You have to prove you exist as a person.
Well, the new concept is KYA, know your agent. We can't ask an algorithm for its driver's license. So we need cryptographic credentials. We need a system where an AI can present a digital signature that proves, I am this software, I'm run by this company, and my spending limit is $50.
So trust shifts from being human to human to algorithm.
Or even algorithm to algorithm. You verify the code in the wallet, not the person. It creates a clear chain of custody for digital actions.
Okay, so we have stablecoins for speed, AI agents for execution, and KYA for security. This all sounds like a pretty robust system. But listening to this, it also sounds like a system run entirely by private tech companies, by Silicon Valley. I can't imagine the Federal Reserve is just sitting back with a bucket of popcorn watching this happen.
Oh, absolutely not. The public sector is waking up fast. This is the Empire Strikes Back moment of the financial world. Governments realize that if they lose control of the money supply, they lose control of the economy.
And this brings us to that acronym of the year, CBDCs, central bank digital currencies. Now, I feel like this term gets thrown around a lot. How is a CBDC different from the numbers I already see in my banking app? I mean, those are digital.
That's a crucial distinction. The money in your banking app is a liability of a private bank, like Chase or Wells Fargo. If that bank goes bust, you're relying on insurance, like the FDIC, to get your money back.
Yeah.
A CBDC, on the other hand, is a direct liability of the central bank itself.
So it's the digital equivalent of a physical dollar bill in my wallet.
Exactly that. If you hold a physical dollar, it doesn't matter if your local bank closes down. That dollar is backed by the U.S. Treasury. A CBDC is that exact same safety, just in code. And right now, 137 countries, that's 98% of global GDP, are exploring them.
So basically the entire world economy is rebuilding its foundation at the same time.
They have to. The Bank for International Settlements, the BIS, which is like the central bank for all the central banks, they use a great analogy. They say you can't have a digital Wild West. The central bank has to remain the anchor of trust. And they envision a pyramid.
Okay, walk me through the pyramid.
Right, so at the very top, the peak, you have the CBDC. It's public, it's totally secure, it's the ultimate settlement layer, the bedrock. Then at the base of the pyramid, you have the private sector innovation.
Stable coins, tokenized bank deposits, that kind of thing.
Exactly. So the idea is the government builds the highway and the private sector builds the race cars. You let the private sector innovate on speed and programmability for these machines. Because, frankly, central banks are not great at user interface. But everything eventually settles back to the ultimate safety of the central bank's money.
That sounds like a pretty nice cooperative future. Everyone holds hands. But reading through the geopolitical section of our source material, it doesn't look like everyone is holding hands. It looks like they're building fences.
No. This is where the story gets more complicated. Money is never neutral. And the money of machines is fast becoming a geopolitical battlefield. We have to look at China.
The digital yuan?
The ECNY. They are miles ahead of everyone else. They've already processed nearly $1 trillion in transactions. But the real story isn't just domestic use. It's a project called mBridge.
mBridge. It sounds like a generic startup name, but it's actually a coalition.
It is. It connects the central banks of China, Thailand, the UAE, and Hong Kong. And it allows them to settle payments between their countries instantly using their own digital currencies.
And the subtext here is what they aren't using.
They aren't using the US dollar, and they aren't using the SWIFT system.
Which is the current messaging system for global banking, heavily influenced by the US.
Yeah.
It's what we use for sanctions. If we want to cut a country off, we kick them off SWIFT.
Exactly. So mBridge creates a completely alternative rail. It reduces reliance on the dollar and on American influence. If machines in Asia can trade with machines in the Middle East instantly, without ever touching a US dollar or a US-controlled network, that is a massive shift in global power.
So naturally, the West is responding. I read about the Genius Act in the notes.
The Genius Act in the U.S. is fascinating. It's basically an attempt to say, okay, if the world is going digital, let's make sure they use digital dollars. It promotes dollar-backed stablecoins. The logic is, even if the money is privately issued, as long as it's pegged to the dollar, the U.S. maintains its financial dominance.
And Europe. They seem like they're caught in the middle.
Europe is terrified of being squeezed. They're accelerating the digital euro because they do not want a future where European machines are forced to choose between American stablecoins or the Chinese digital yuan.
This leads to a really strange implication then. If we play this out, it suggests that the currency a machine uses might depend on where it was made.
Or who programmed its operating system. Imagine a future where you buy a smart washing machine made in Munich. It might be hard-coded to pay for its own detergent using digital euros. But if you buy a delivery drone made in Shenzhen, it operates on the ECNY network.
It's the balkanization of money.
It is. We're moving from a world where money was a kind of universal solvent to a world where money is hard-coded into a device's OS. The currency it uses determines which power block dominates that slice of commerce.
That is a lot to process. We started with a robot needing a wallet to pay for electricity, and we've ended up in a global geopolitical standoff over digital currency protocols.
It escalates quickly, but that's the nature of infrastructure, right? It seems boring until you realize it controls everything.
So let's try to synthesize this. If we look at the money of machines as a whole, what are its core traits? If a listener wants to explain this without boring everyone at a dinner party, What are the four pillars?
I'd summarize it like this. This new money is programmable, instant, autonomous, and geopolitical.
Let's do a rapid fire. Programmable.
It can be designed to be spent only under certain conditions. It's smart money that knows what it's buying and when.
Instant.
24/7 settlement, no banking hours. The speed of money finally matches the speed of data.
Autonomous.
It's managed by AI agents. The user isn't a human anymore. The user is code.
And finally, geopolitical.
It's a tool for state power. The code itself carries the influence of the nation that backs it.
It really forces us to rethink our own role in the economy. I mean, we're building this incredibly fast, efficient system, but it raises so many new questions. How do you regulate an economy where the participants are not people?
That is the regulatory headache of the century. And what about privacy? If every single micropayment a machine makes is recorded on a ledger, and those machines are interacting with us, buying our data, serving us content, every interaction becomes traceable.
It feels like we're building a financial highway that allows traffic to move at the speed of light. But we haven't quite figured out if we're building it for us or just to make the machines' lives easier.
That is the ultimate question to leave with. We are creating a system that optimizes efficiency for algorithms. The challenge isn't technical anymore. We know how to build it. The challenge is ensuring this machine money actually improves human life. Does it free us from drudgery? Does it compensate creators fairly? Or does it just create a hyper-efficient loop where machines trade with other machines and we're just left watching from the sidelines?
That's a provocative thought. We're building the wallet for the machine, but we need to make sure we keep the keys to the house.
Well put.
Thanks for diving deep with us today. This is a topic that is only going to get bigger, so keep your eyes and your digital wallets open.
Until next time.
See you in the future.